Question 11. We get this somewhat funky equation, and we're told it has a minimum at m, and a minimum point means the gradient is going to be 0. We are told to find the exact coordinates of m, and so let's use that the gradient is going to be 0. First thing we have to do is the derivative of the function, and so dy dx, the power comes down, so the negative 2 on 3 multiplies by 2, the x goes there, and we subtract 1. When you subtract 1 from negative 2 on 3, you're subtracting another 3 on 3, so it becomes negative 5 on 3. And then we're going to minus, this time the power is negative a third, so negative a third comes down, multiplies by the 3. And the x, we subtract 1 from negative 1 on 3 and becomes negative 4 on 3. We differentiate 1, it disappears when you differentiate it, so it's not there anymore. Let's just simplify this a little, and so we'll get negative 4 on 3, x to the negative 5 on 3, plus x to the negative 4 on 3. Now we're trying to find where the gradient is 0, which means this equation that we just found equals 0. Now whenever something equals 0, one of the main ways we solve is to factorize. And we look at it and say, can we factorize anything out of these? Well, we need to know our index laws, and we would say, yeah, we can. Let's just take the x to the power of negative 4 on 3 out. And if we take that out, the first term, we're asking the question, what do you multiply x to the negative 4 on 3 by to get x to the negative 5 on 3? Because we have to reconstruct that. When you multiply powers, what do? You add the indices. And so what do I add to negative 4 on 3 to get negative 5 on 3? Well, that's just negative 1 on 3. And so that is our power in the bracket. And the second term is plus 1 because we took the whole term out. Now we're multiplying these two things to be 0. So either the first one is 0, which, let's make it a positive power, 1 over x to the positive 4 on 3 equals 0. Hopefully we realize it's not possible. You can't get 0 by dividing 1 by anything. So that's not going to be an answer. Let's go to the brackets then and make the index positive again. So we'll have negative 4 over 3 times the cube root of x plus 1 equals 0. We take the 1 over to the other side. That will make it negative. Then we can take the cube root of x up to the other side to bring it to the top of the fraction, and let's take the negative 1 down at the same time. So the negative 1 comes to the front, is going to divide into the negative 4 and make it positive. So now we just have 4 on 3 equals the cube root of x. So x is 4 on 3 cubed, which is 64 over 27. We need the m coordinate as well, which now means we have to take the x coordinate and put it back into the original function. All right, it may help if we make the powers positive, like a negative power can be a little confusing. So let's make them positive and put it in. We'll get y equals 2 divided by the cube root of 64 over 27 squared. Now that's nice because the cube root of 64 over 27 is kind of going back to what we already came from, which is just the 4 on 3. Okay, so it's kind of handy that we're doing the cube root. And the next term will be minus 3 over the cube root of 64 on 27 plus 1. All right, so the cube root 64 on 27 turned into 4 on 3. And for the first term there, we're going to square it, so that will turn into 16 over 9. But we have a fraction divided by a fraction, so the 16 stays on the bottom, the 9 comes up to the top. For the second one, it's just 3 divided by 4 on 3, which is 3 divided by 4, and the other 3 comes up to the numerator and multiplies by the 3, plus 1. I guess you could have put the previous line in a calculator, but you can put this line in a calculator. It's going to turn into minus 1 over 8. So our point m is 64 over 27. And negative 1 over 8. And finally, for part B, we have find the area of the region bounded by the curve and the line segment AB. Lab is along the x-axis, and it's where the curve cuts the x-axis, so that's the roots. We need to find the x-intercept, so the function is going to equal 0. So when the function equals 0, we want to factorize and then either factor equals 0. And we look at it, and you wouldn't be able to make progress unless you realize, oh, this is a quadratic where the variable is pretty much x to the negative 1/3. Because if you square x to the negative 1/3, you get x to the negative 2/3. So why don't we make this easier for ourselves and write u is x to the negative 1/3. And then the function becomes 2u squared minus 3u plus 1 equals 0. Oh, it looks a whole lot nicer. What multiplies to 2 adds to negative 3? Well, that would be negative 2 and negative 1. So let's break minus 3u up into those two terms and factorize out as much as we can. We get 2u, u minus 1, and then we need to take out negative 1 to get another u minus 1. Bringing us to 2u minus 1 multiplied by u minus 1 is equal to 0, which means u is a half, or u equals 1. Right, so let's put x to the negative 1/3 back in. Well, to make the index positive, we're going to put it on the denominator of a fraction, and 1/3 means the cube root. So we have 1 over the cube root of x is equal to 2, or 1 over the cube root of x equals 1. All right, so you can just flip those fractions because you have a fraction on both sides of the equal sign. The cube root of x is equal to 2, so x equals 2 cubed. 2 cubed is 8, x is 8. On the other one, hopefully it's obvious that x has to be 1. The cube root of 1 is 1, 1 divided by 1 is 1. Okay, so we have the two x-intercepts. That would be our first stage. To find the area, we are now going to integrate from 1 to 8 of the function with respect to x. So the first thing we have to do here is an integration. Now, to do an integration, it's in a sort of polynomial form. We take the power, well, we add 1 to the power. Integration, not differentiation. Add 1 to the power, and so you have negative 2/3 plus 1 is positive 1/3. And then we're going to divide by the power, which it's multiplied by the reciprocal of the power is a much nicer way to do this. And so we're going to have 3 times what was already at the front, 2, and x to the 1/3. Okay, for the second term, we have x to the negative 1/3, but we're going to add 1, so we'll end up with x to the 2/3. We need to multiply by the reciprocal, and so we're going to put a 3 on 2 at the front. The minus sign stays there, and we're multiplying 3. When we integrate 1, we get x, and that's it. We have our boundaries 1 to 8. All right, we can make this look a little nicer, maybe, so when we put in our boundary values, it makes a lot more sense for us. When you have x to the 1/3, that means the cube root of x, so we can turn this into 6 times the cube root of x minus 9 on 2 times the cube root of x squared. Now, it doesn't matter if you do the squared first or second in order of the cube root and the square, and plus x. Alright, so it's still a boundaries 1 to 8, and we put 8 in first. Now the cube root of 8 is nice because that turns into 2, so we have 6 times 2 minus 9 on 2 times the cube root of 8 again is 2, and then square it, we get 4, plus, and just put 8 in. Minus, we're going to put in 1 this time, so 6 times 1 is just 6, and if you do the cube root square 1, you just still get 1, so we're minusing 9 on 2, and then this time plus 1. We can do some more simplification here. 6 2s are 12, 4 cancels with the 2 to make 2, so we get minus 18 plus 8 minus, in the other brackets, 6 plus 1 is 7 minus the 9 on 2. Oh, look, let's throw it in a calculator. And we get minus a half. Okay, that's what we expected because the area is under the x-axis, so hopefully we were expecting a negative answer. That's not the area, that's the integration between the two boundaries. But the area is the positive representation of that, and so we would write the area is a half square units. And we are done.